In the vast expanse of our solar system, the quest for extraterrestrial life has led scientists to some of the most unexpected and distant corners. One such destination, rich with the potential for harboring life, is Saturn's icy moon, Enceladus. And in a stunning revelation, researchers have just unveiled astonishing evidence suggesting this small, bright moon, only about 500 kilometers in diameter, has become one of the most promising candidates for finding life beyond Earth. But what exactly have the experts found on the icy moon? Is humanity standing on the cusp of a new era where the search for extraterrestrial life could be dramatically altered forever? All this and more will be discussed in today's episode. Enceladus was first discovered by the German-born British astronomer William Herschel in 1789. However, it remained largely unremarkable for nearly 2 centuries, overshadowed by its larger siblings in the Saturnian system, like Titan. It wasn't until the late 20th century, with the arrival of advanced spacecraft like Voyager and later Cassini, that Enceladus began to reveal its secrets. The Voyager missions of the early 1980s provided the first close-up images of Enceladus, showing a bright, icy surface with a striking lack of craters. This suggested that the moon was geologically active, resurfacing itself and erasing the evidence of past impacts. However, it was the Cassini-Huygens mission, launched in 1997 and arriving at Saturn in 2004, that truly revolutionized our understanding of Enceladus. Cassini's exploration of Enceladus began in earnest in 2005, when the spacecraft made its first close flyby of the moon. What it found stunned the scientific community. Cassini has been making discovery after discovery that has catapulted Enceladus to one of the top places to look for life beyond Earth. In particular, we learned Enceladus has a liquid water ocean beneath its icy surface, heated by gravitational tidal forcing, the kind of forcing that produces ocean tides on Earth. This environment is tantalizingly similar to the hydrothermal vents thought by some to be the place where life may have originated on Earth. Such vents certainly host life on Earth today. Most life on Earth ultimately relies on photosynthesis, generating energy from sunlight. Meanwhile, the ultimate energy source for any life on Enceladus would be the gravity of Saturn producing tides far stronger than the moon produces on Earth, allowing a liquid water ocean despite the very cold 200°C ice crust surface. The Enceladus plumes have been called a gimme for efforts to sample the oceans of alien worlds. One wouldn't need to land to collect a sample, nor to then launch to return it for analysis. An obvious approach to sampling an ice volcano is to simply fly through it. However, this is difficult because the speed at which a space probe would encounter the plume would likely kill most organics. Instead, the easiest approach is to examine the accumulation of ejected material from Enceladus in Saturn's ring, which is what the team did in this latest study. Using this approach, researchers have previously discovered complex organic molecules coming from Enceladus. These findings confirmed that the watery environment on Enceladus supports complex chemistry involving nitrogen and oxygen. However, until now, we didn't know about the availability of phosphorus on Enceladus. Phosphorus is a vital ingredient because it is needed for the phosphate groups, phosphorus plus oxygen, that link the long chains of nucleic acids, such as DNA and RNA, that store genetic information. It also allows cells to store energy by means of molecules, such as adenoside triphosphate, ATP for short. Of course, we don't know for sure that life inside Enceladus, if it exists, is obliged to use nucleic acids or ATP. However, because the presence of phosphorus is essential for life as we know it, it makes Enceladus a more likely prospect now that we are certain that there is enough phosphorus available there. And as expected, the intriguing new findings estimate that concentrations of phosphorus on Enceladus are at least 500 times higher than the highest known concentrations in Earth's oceans. The discovery shows that the icy moon, already one of the hottest candidates in the search for alien life, now satisfies the strictest requirement of habitability. The team found Enceladus's phosphorus by avoiding the cluttered data collected during the Cassini's frantically quick zooms through the plumes. Instead, they scoured sparser data accumulated in a more leisurely fashion by Cassini's cosmic dust analyzer during 15 periods between 2004 and 2008, while Cassini was traveling within one of Saturn's rings, the E-ring. Enceladus travels along this hoop as it orbits. The E-ring hoop is more than 2,000 kilometers thick. About 30% of the ice particles emitted in Enceladus's plumes end up there, as demonstrated by a recent image from the James Webb Space Telescope, which is the only proof we have that the plumes were still active 5 years after the end of the Cassini mission. Sorting through analyses of nearly 1,000 ice particles, which are believed to represent frozen spray from Enceladus, the researchers found 9 of them that contained phosphates. This may sound like a slim haul, but it is enough to demonstrate that Enceladus has more than enough dissolved phosphorus in its ocean to permit the functioning of life there. Indeed, follow-up laboratory experiments suggest that the concentration of dissolved phosphorus in Enceladus's ocean water may even be hundreds of times greater than in Earth's oceans. The discovery has implications beyond Enceladus's corner in the solar system. Phosphorus is quite rare in natural waters, as it readily reacts with positively charged atoms like calcium to form calcium phosphate, which locks up the phosphorus and thus makes it unusable for life forms. But Enceladus is able to host such high amounts of dissolved phosphorus because it has what scientists call a soda ocean. Soda oceans, or soda lakes, are rich in carbonates, minerals that contain carbon dioxide and form easily in water. Carbonates bond with other elements, like calcium, leaving phosphorus available for potential life to use. This process can be witnessed on Earth, too. California's Mono Lake, Nevada's 2 soda lakes, and the Borax Lake in Oregon are just a few examples of soda lakes where rich ecosystems are able to survive. Elsewhere in the world, Africa, Asia, and Europe are known to harbor similar soda lakes. In the solar system, celestial objects which host oceans beyond the frost line, the arbitrary point in the system between the asteroid belt and Jupiter's orbit, beyond which carbon and ice begin to condense into solid ices, would inevitably have a soda ocean. After all, with many of the essential components necessary for the emergence of life, as we know it, have thus been discovered on Enceladus, this puts it at or near the top of lists of places to search for life beyond Earth in our solar system. Nevertheless, this discovery is only the start of the story. For phosphate to form bonds with carbon, this type of bond is found in the backbone of DNA. We need specialized chemistry that's very dependent on the environment. We'll need further study of the chemistry in and under the crust of Enceladus. Fascinatingly, several mission concepts have been proposed to further investigate the potential for life on Enceladus. These include flyby missions that would sample the plumes in greater detail, as well as more ambitious proposals for landers or even probes that could penetrate the ice shell and explore the ocean directly. One of the most promising mission concepts is the Enceladus Orbilander, which would combine an orbiter and a lander in a single spacecraft. The orbiter would study the moon from above, mapping its surface, analyzing the composition of the plumes, and searching for signs of habitability. The lander, meanwhile, would touch down on the surface, possibly near one of the active geysers, and conduct detailed studies of the ice and any material that may have been deposited by the plumes. Another concept is the Enceladus Life Finder, also known as ELF, a proposed mission that would fly through the plumes and use advanced instruments to search for biosignatures, indicators of life, such as specific patterns of organic molecules or isotopic ratios that are unlikely to be produced by non-living processes. While these missions remain in the proposal stage, the interest in Enceladus is high, and it is likely that future missions will be launched to further explore this intriguing moon. The search for life on Enceladus is not just about finding organisms in a distant ocean, it's about answering fundamental questions about the nature of life in the universe. If life can exist on Enceladus, it would suggest that life is not a rare phenomenon, but rather a common outcome of the right environmental conditions. That simply would have profound implications for our understanding of the universe and our place within it. For centuries, humanity has wondered whether we are alone in the cosmos. The detection of even the most primitive life forms on another world would suggest that life is not unique to Earth, but rather a natural consequence of the right combination of ingredients and conditions. Such a discovery would also have significant implications for the field of astrobiology, the study of life in the universe. It would provide a second example of life, allowing scientists to compare and contrast it with life on Earth. This, in turn, could lead to a better understanding of the fundamental principles that govern the emergence and evolution of life. Moreover, finding life on Enceladus would raise new questions about the distribution of life in the solar system and beyond. If life can exist on a small, icy moon with a subsurface ocean, it might also be present on other icy bodies, such as Europa, another moon of Jupiter, or even on distant exoplanets with similar conditions. The discovery would fuel the search for life in other parts of the solar system and potentially beyond. While the potential for life on Enceladus is exciting, there are significant challenges to overcome. One of the primary challenges is ensuring that future missions to Enceladus do not inadvertently contaminate the moon with Earth life. This is crucial because it could compromise the search for indigenous life forms and make it difficult to distinguish between Earth-born organisms and potential Enceladan life. Additionally, the harsh conditions on Enceladus, extreme cold, high radiation levels, and the difficulty of accessing the subsurface ocean pose technical challenges for exploration. Developing the technology to safely and effectively explore Enceladus, whether by sampling the plumes or drilling through the ice, will require significant advancements in engineering and planetary protection. Despite these challenges, the scientific community remains optimistic about the prospects of exploring Enceladus further. The discoveries made by the Cassini mission have opened a new chapter in the search for life in the solar system, and Enceladus stands out as one of the most promising locations for finding answers to some of the most questions in science. On the other hand, note that the deeper we look into space, the more places we come across that maybe, just maybe, could host life. From our neighboring planets to distant galaxies sending out weird signals, the list of spots in space worth checking out just continues to grow. And here are the best places to search for life in our vast universe. 1. Mars, the red planet. Mars has captivated human imagination for centuries as a potential abode of life. The discovery of dried-up riverbeds, polar ice caps, and minerals that form in liquid water strongly suggest that Mars once had a more temperate climate and liquid water on its surface, key ingredients for life as we know it. Although the surface of Mars today is harsh and inhospitable, with extreme cold, radiation, and a thin atmosphere, the possibility of life cannot be ruled out. NASA's Perseverance rover, currently exploring the Jezero crater, is on a mission to search for signs of ancient microbial life. The crater was once home to a lake, making it an ideal location to find preserved biosignatures. Perseverance is equipped with sophisticated instruments designed to analyze soil and rock samples for organic molecules, the building blocks of life. If life ever existed on Mars, evidence might still be trapped in its subsurface, shielded from the harsh surface conditions. 2. Europa, Jupiter's icy moon. Europa, one of Jupiter's largest moons, is a prime candidate in the search for extraterrestrial life. Beneath its thick ice crust lies a subsurface ocean, which could contain twice as much water as all of Earth's oceans combined. This vast ocean, kept warm by tidal forces from Jupiter's gravity, might be an ideal environment for life. The icy shell of Europa is constantly being resurfaced, which suggests that the ocean beneath could be interacting with the surface, possibly bringing nutrients and energy sources from the moon's interior. The upcoming Europa Clipper mission, set to launch in the 2030s, will conduct detailed reconnaissance of Europa's ice shell and subsurface ocean. It will look for conditions suitable for life and attempt to identify any potential biosignatures. 3. Titan, Saturn's largest moon. Titan, the largest of Saturn's moons, presents a unique environment in the search for life. Unlike any other body in our solar system, Titan has lakes and rivers of liquid methane and ethane on its surface, and a thick atmosphere rich in organic compounds. While its surface temperature is far too cold for liquid water, the possibility of life, perhaps life forms that use methane instead of water as a solvent, cannot be dismissed. Titan's subsurface ocean of water mixed with ammonia adds another layer of intrigue. The Huygens probe, which landed on Titan in 2005, revealed a landscape shaped by both erosion and deposition, similar to Earth's. The upcoming Dragonfly mission, planned for the mid-2030s, will explore Titan's surface and atmosphere in detail. This rotorcraft lander will investigate the prebiotic chemistry of Titan and assess its potential habitability. 4. Venus, Earth's twin with a twist. Venus, often referred to as Earth's twin due to its similar size and proximity to the Sun, presents a paradox. While its surface is a hellish environment with temperatures hot enough to melt lead and a crushing atmosphere, the upper layers of its thick clouds offer a potential haven for life. In 2020, the detection of phosphine gas in Venus's clouds, an unexpected and controversial finding, sparked renewed interest in the planet as a candidate for hosting life. Phosphine on Earth is produced by microbial life in oxygen-free environments. If this gas is indeed present in Venus's atmosphere, it raises questions about its origin, as known non-biological processes should not produce it in the observed quantities. While the surface of Venus is extremely inhospitable, the cloud tops, where temperatures and pressures are more Earth-like, could potentially harbor microbial life. Future missions to Venus, such as the Veritas and Da Vinci Plus missions, aim to further investigate its atmosphere and surface. 5. Exoplanets in the habitable zone. Beyond our solar system, thousands of exoplanets have been discovered, with many located in the so-called habitable zone, the region around a star where conditions might be right for liquid water to exist. These exoplanets represent the most tantalizing targets in the search for life, as some could be Earth-like in size and composition. One of the most studied exoplanets is Proxima Centauri b, located just 4.34 light-years away in the habitable zone of the star Proxima Centauri. Another promising candidate is TRAPPIST-1e, one of 7 Earth-sized planets orbiting the ultra-cool dwarf star TRAPPIST-1. These planets are of particular interest because they are close enough for us to study their atmospheres in detail using the James Webb Space Telescope. Launched in December 2021, James Webb has already begun providing detailed observations of exoplanet atmospheres, searching for signs of water vapor, methane, and other potential biosignatures. The discovery of these elements could hint at the presence of life, or at least the potential for habitability. While the search for microbial life focuses on natural biosignatures, another avenue of exploration is the search for technosignatures, evidence of advanced civilizations. This includes detecting radio signals, laser emissions, or even the dimming of a star caused by massive structures like Dyson spheres. For those who don't know, the idea behind a Dyson sphere is to collect as much energy from a star as possible. On Earth, the total amount of energy we receive from the Sun, a value known as the total solar irradiance, is 1,361 watts per square meter, as measured by NASA's Solar Radiation and Climate Experiment. But that is just a tiny proportion of the Sun's total energy output, radiated in all directions, which is 380 billion quadrillion watts every second. Because Earth is so small by comparison, we receive only a tiny proportion of this energy. However, suppose that an enterprising technological civilization wanted to make use of all their stars' energy that would otherwise move off into space at the speed of light. If they had sufficiently advanced technology, they might build themselves a Dyson sphere, a spherical swarm of solar energy collectors that would fully encapsulate their star and collect all of its energy. Scientists who study the search for extraterrestrial intelligence, also known as SETI, categorize a civilization with a Dyson sphere as a Kardashev Type 2 on the Kardashev scale, meaning it's capable of utilizing all the energy from a star in the region of 1026 watts per second. This value varies from star to star, as some stars are more or less luminous than the Sun. A Type 1 civilization utilizes all of the energy available to a single planet, fossil fuels, renewable energy sources, and nuclear power, which is calculated to be about 1016 watts per second. And a Type 3 civilization utilizes all the power in an entire galaxy by building Dyson spheres around every star and taking energy from the central supermassive black hole, and attains 1036 watts per second. If you're wondering where we rate on that scale, we're currently a Kardashev Type 0.7449 civilization. We don't even make full use of all the energy available to us on Earth. The Breakthrough Listen project is one of the most ambitious efforts in this domain, using the world's largest radio telescopes to scan the skies for artificial signals. Although no definitive signals have been found so far, the search continues, expanding to new targets and frequencies. The discovery of technosignatures would not only confirm the existence of intelligent life, but also offer profound implications for our understanding of the universe. As our understanding of the cosmos grows, so too do the methods and technologies we employ to search for life. Future missions and projects are poised to expand our reach, both within our solar system and beyond. For example, the Europa Clipper and Dragonfly missions will provide unprecedented data on the habitability of icy moons. Moreover, the development of next-generation telescopes, such as the Extremely Large Telescope, ELT, and the Giant Magellan Telescope, GMT, will allow us to study exoplanets in even greater detail, potentially identifying more candidates for life. These instruments will be capable of analyzing the atmospheres of exoplanets with incredible precision, looking for chemical imbalances that might indicate biological processes. The search for life beyond Earth is a journey that spans the vastness of space and the depths of time. From the ancient riverbeds of Mars to the icy oceans of Europa and Enceladus, and the distant exoplanets bathed in the light of alien suns, each location offers a unique glimpse into the potential for life elsewhere in the universe. As our technology advances and our understanding of the cosmos deepens, we move ever closer to answering the age-old question: are we alone? Whether we discover microbial life on a distant moon, detect the chemical signatures of an alien atmosphere, or receive a signal from a distant civilization, the implications will be profound, forever changing our place in the universe. Until that day comes, the search continues, driven by our innate curiosity and the hope that somewhere out there, life has taken hold. But if intelligent life exists elsewhere in the universe, what might it look like? The most iconic image of an alien, popularized by countless science fiction movies, is the Gray, a humanoid figure with large black eyes, a bulbous head, and slender, childlike bodies. This image has become so ingrained in our collective consciousness that it's often the first thing that comes to mind when people think of aliens. But why has this particular form taken such a hold on our imagination? The answer lies in a combination of cultural and psychological factors. The gray alien archetype first gained prominence in the mid-20th century, notably through the alleged encounters described by individuals like Betty and Barney Hill. The grays represented a blend of the familiar and the unfamiliar. Their humanoid form made them relatable, yet their exaggerated features added an element of the uncanny. However, this image is only one of many possible representations of extraterrestrial life. In truth, the potential diversity of alien appearances is as vast as the universe itself. To speculate on what aliens might look like, we must first consider the principles of biology and evolution. Life on Earth has evolved under specific conditions: gravity, atmospheric composition, temperature, and available resources. These factors have shaped every living organism, from the simplest bacteria to the most complex animals. If alien life exists, it would have evolved under different conditions, leading to potentially vastly different forms. For instance, consider the role of gravity. On a planet with stronger gravity, life forms might be shorter and stockier, with powerful muscles and thick bones to support their weight. Conversely, on a planet with weaker gravity, beings might be taller and more fragile, with elongated limbs and delicate structures. Atmospheric composition would also play a significant role in shaping alien physiology. Earth's oxygen-rich atmosphere has led to the development of aerobic respiration, but on a planet with a different atmosphere, life might rely on entirely different chemical processes. For example, in a methane-based environment, life forms could have silicon-based biochemistry instead of carbon-based, potentially leading to organisms that look more like living crystals than flesh and blood. The way aliens perceive their environment would also influence their appearance. On Earth, sight is a dominant sense for many species, but this is not a universal rule. In environments where light is scarce or non-existent, other senses might take precedence. For example, in the deep oceans of Earth, many creatures rely on sonar or electroreception to navigate and hunt, leading to vastly different sensory organs compared to land-dwelling animals. In a similar vein, alien species that evolved in environments where vision is less useful might have developed heightened senses of touch, smell, or hearing. They might possess elaborate antennae, sensitive to the faintest vibrations, or complex olfactory structures, capable of detecting minute chemical changes in the air. Moreover, alien species could have sensory organs completely unfamiliar to us, such as the ability to detect magnetic fields, infrared radiation, or even the passage of time. These senses would not only shape their behavior, but also their physical forms, leading to beings that might be completely unrecognizable as living creatures by human standards. The development of intelligence and technology is another factor that could dramatically influence the appearance of alien beings. On Earth, humans have evolved a large brain relative to our body size, leading to our distinctive skull shape. If intelligence is a common trait among advanced extraterrestrial species, they too might have developed large brains, but the form this takes could be very different. For instance, on a planet where energy is scarce, evolution might favor beings with smaller, more efficient brains, relying on collective intelligence or hive mind structures rather than individual cognition. In addition, in environments where technology plays a central role in survival, alien beings might have integrated machinery into their bodies, leading to cybernetic organisms that blur the line between biology and technology. Furthermore, the way aliens interact with their environment could lead to unique physical adaptations. Species that have developed advanced technology might have evolved to prioritize dexterity, leading to multiple limbs or specialized appendages for manipulating tools. Alternatively, a species that has integrated artificial intelligence into their biology might have neural interfaces or other forms of direct brain-computer connections. Just as human cultures have shaped the appearance and behavior of different societies, alien cultures would also influence the appearance of their species. Cultural practices, such as body modification, clothing, or grooming, could lead to a wide variety of appearances within a single alien species. For instance, a species that values symmetry might develop elaborate rituals to enhance or emphasize symmetrical features, leading to a society where individuals have artificially modified bodies that reflect cultural ideals. Additionally, the environment in which a species evolved would play a critical role in shaping its appearance. On a planet with extreme temperatures, for instance, life forms might develop thick, insulating layers or specialized cooling systems. In underwater environments, creatures might have streamlined bodies and fins, while those on land might develop limbs suited for climbing, burrowing, or running. Another intriguing aspect to consider is how alien psychology might influence their appearance. If a species has a different psychological makeup from humans, it could lead to physical forms that reflect those differences. For example, a species that evolved to be highly social might have features that emphasize communication, such as large, expressive eyes, complex facial muscles, or even bioluminescent patterns used for signaling. Conversely, a species that evolved in a solitary or hostile environment might have a more intimidating appearance, with features designed for defense or aggression, such as sharp claws, spines, or tough armored skin. These physical traits would not only reflect their evolutionary history, but also their psychological tendencies, leading to beings that are as much a product of their minds as their bodies. Beyond biology, the role of artificial life. In addition to biological life, we must also consider the possibility of artificial life forms. If a civilization has advanced to the point where it can create life, either through genetic engineering or artificial intelligence, the appearance of these beings could be anything imaginable. These life forms might be designed for specific tasks or environments, leading to a wide variety of forms that reflect their intended functions. For example, a species that has colonized multiple planets might create different forms of artificial life for each environment, leading to a vast diversity of appearances within a single civilization. These beings could range from tiny, insect-like robots designed for precision tasks to massive, tank-like creatures built for heavy labor or defense. Additionally, the concept of virtual beings must be considered. In a highly advanced civilization, individuals might choose to exist in digital form, abandoning physical bodies altogether. These virtual beings could take on any appearance they desire, further expanding the possibilities of what alien life might look like. Despite all these possibilities, it's important to recognize the limitations of human imagination. Our understanding of biology, physics, and technology is based on our experiences on Earth, and while we can speculate on what alien life might look like, the reality could be far stranger and more complex than anything we can conceive. For example, some scientists have proposed the existence of life forms based on completely different principles from those on Earth, such as beings made of dark matter or life that exists in higher dimensions. These concepts are difficult to visualize, but they remind us that the universe is vast and filled with possibilities beyond our current understanding. In the end, the question of what aliens look like is as much a reflection of our curiosity and imagination as it is of scientific inquiry. While we may never know the true appearance of extraterrestrial beings, the exploration of this question challenges us to expand our understanding of life and the universe, pushing the boundaries of what we consider possible. The appearance of aliens, should they exist, is likely to be as varied and diverse as the environments they inhabit. Influenced by factors ranging from gravity and atmospheric composition to culture, technology, and psychology, the possibilities are nearly endless. While our imagination often gravitates toward the familiar, humanoid forms with slight variations, the true diversity of life in the universe is likely far beyond anything we can currently conceive. As we continue to explore the cosmos, both through telescopes and perhaps one day through direct contact, our understanding of what it means to be alive and intelligent will undoubtedly evolve. In the meantime, the question of what aliens look like remains one of the most tantalizing mysteries of our time, a mystery that invites us to look beyond the familiar and into the vast unknown. That's all the information that we have for you today. Don't forget to give us a thumbs up if you enjoyed today's episode, subscribe if you haven't already, and hit the bell so you never miss out on future episodes. And be sure to also tell us what you think about today's content. Everyone's support motivates us to continue delivering quality content and to always improve. As always, thanks for watching, and we will see you next time. Mercury should already be a dead planet. Scientists thought the humble hunk of rock that's only slightly girthier than Earth's moon would have been battered to barrenness by the sun's intense solar radiation. It's a hostile world. The day and night sides of the planet see a temperature difference of nearly 600 degrees Celsius. But Mercury has proved to be a world of contradictions, a dynamic planet that hides more surprises than scientists initially gave it credit for. A thin atmosphere, a magnetic field, and a stash of volatile compounds still persist on Mercury, features that scientists usually associate with planets that are larger and farther away from the Sun. While new observations from the last few decades have given scientists good cause to revise their opinion of Mercury.
Mercury is basically a big ball of metal surrounded like a tiny bit of rock. And the major question is, why? Why is it like this when the rest of the planets aren't?
Its secrets remain. But now, by using powerful telescopes, scientists have stumbled upon these secrets. But what they found is so weird. There is something moving that they never saw anywhere else. Such a stunning revelation could even lead to crucial missions to reveal a terrifying truth about our universe. Join us as we shed light on the dark shadow that Mercury has kept under wraps. Named for the fleet-footed Roman messenger god, Mercury is the closest planet to the Sun, zipping around our parent star at an average of 36 million miles away. However, Mercury's orbit is not a perfect circle. The planet can pass as close as 29 million miles and as far away as 43 million miles. Living up to its name, Mercury is the fastest planet in the solar system, speeding along at about 29 miles per second and completing each orbit around the Sun in just 88 Earth days. Mercury is also the smallest planet in the solar system, measuring just 3,032 miles wide at its equator. That makes it only slightly larger than Earth's moon. Because Mercury is so small and so close to the Sun, it is the most elusive of the 5 planets that are visible to the naked eye. You can only catch Mercury at dawn and dusk, and it usually does not rise far above the horizon. But that's not the only time the tiny planet makes an appearance. Because of its position in the solar system, Mercury passes between Earth and the Sun 13 times each century in an event known as a transit. During a transit of Mercury, observers on Earth can see the planet in silhouette as it seems to sweep across the Sun's disk. Since ancient times, people observing the heavens have noticed that the naked eye planets sometimes appear to move backward, briefly shifting from their usual eastward motion to a westward path across the sky. This retrograde motion is an illusion created when one planet moves faster in its orbit than another, so that it catches up to and passes the slower world. For observers on Earth, Mercury is in retrograde about 3 to 4 times a year. If you could watch the skies from the surface of Mercury, you would sometimes catch the rare sight of the Sun in retrograde. As Mercury makes its closest approach to our smoldering star, its orbital speed exceeds its rate of rotation on its axis. That means someone standing on Mercury would see the Sun start to rise, then briefly set, then rise again, all within the same day. Like the other planets in the solar system, Mercury was born about 4.5 billion years ago, condensing from the swirling ring of dust and gas left over from the Sun's formation. The small planet cooled very quickly, contracting enough within the first billion or so years to prevent magma from escaping through the outer crust and ending geologic activity such as volcanism on the surface. And while Mercury may be small, it's hefty. Although its diameter is barely larger than the Moon's, Mercury is over 4 times as massive as Earth's natural satellite. In fact, Mercury is the second densest planet in our solar system, after Earth. The planet's extreme density comes from the fact that it has a large iron core that makes up about 60% of the planet's volume. In contrast, Earth's core by volume is only about 15%. The abnormal internal structure has spawned several theories on Mercury's birth. Scientists think that perhaps early Mercury's outer layer was boiled away by the sun or scattered by solar winds. Or perhaps the young planet could have been struck by a large impactor that stripped away most of the softer outer layer, leaving behind its sturdier heart. Since part of the mantle and crust are still present today, this suggests that the collision may not have been a head-on smack, but a glancing brush that preserved some of Mercury's original layers. The first mission to Mercury, Mariner 10, was launched in 1973 and found that Mercury still sustains a magnetic field. The discovery came as a shock to the scientific community, who had assumed that such a small planet would have rapidly cooled, and its insides would have congealed, thereby losing any means of magnetism at the global scale. The presence of a magnetosphere implies that part of Mercury's core is still churning. Mercury's magnetic field is about 100 times weaker than Earth's on their respective planetary surfaces. The sluggish dynamo means that the planet is at the tail end of its developmental stage, on its way to becoming a dead planet like Mars. In the 2010s, the second Mercury mission, Messenger, documented that the planet's magnetic field is off-kilter. The magnetic South Pole doesn't sit on the geographic South Pole. Instead, it is buried almost at the center of the planet. The magnetic field offers a glimpse of the planet's interior and a snapshot of its history, hinting at how far the whirling insides have decelerated over billions of years. Due to its proximity to our star, Mercury is hot. If we're being quantitative, it's actually extremely hot. As the closest planet to the Sun, it completes an orbit in just 88 Earth days, achieving a maximum temperature during the day of a whopping 427 degrees at its hottest equatorial locations. Mercury rotates very slowly, so its night side spends a consecutively long time in the dark, shielded from the sun. During those times, it gets down to just minus 173 degrees. That low temperature is incredibly cold, and far colder than any known naturally occurring temperatures here on Earth. But despite being the closest planet to the Sun, Mercury is not the hottest planet in the solar system. Venus is about twice as far from the Sun on average as Mercury is, taking about 225 Earth days to orbit the Sun. It also rotates even slower than Mercury, spending more than 100 consecutive Earth days at a time bathed in sunlight, and then an equal amount of time in darkness. And yet, when you measure the temperature of Venus, there's a surprise. Venus is the same temperature at all times, day or night, at an average of 462 degrees, making it even hotter than Mercury. This strange occurrence did more than just puzzle astronomers when they first discovered it. It mortified them. Venus wasn't large enough to generate its own heat, and yet it was hotter at Venusian midnight than at Mercurian high noon. Why is that? Well, that is because of the main difference between the two worlds. Venus has a very substantial one that's some 190 times as thick as Earth's is, but Mercury, instead of a substantial atmosphere, has such a thin atmosphere that it doesn't really qualify as an atmosphere. Instead, scientists call this wispy layer of gas an exosphere, where the gas is so rarefied that it hardly registers a pressure reading. Mercury takes a constant beating from the Sun, so its exosphere has to regenerate itself from the surface. Since the 1980s, astronomers have detected in Mercury's exosphere atomic sodium, potassium, and calcium, metals with strong emission signals that can be observed all the way from Earth with telescopes. These metallic elements are not usually thought of as gases, but they find their way into Mercury's skies by dint of solar particles and meteorites striking the planet's surface. Solar winds gouge the resulting exosphere, and the interactions between the gases and sun-flung particles fashion a 15-million-mile-long glowing tail behind Mercury. This tail lengthens and shrinks seasonally, depending on Mercury's proximity to the Sun. If you were standing on Mercury and looking up at the right time of the year, Mercury's long tail would appear in the sky as a faint orange glow, as if the heavens were illuminated by sodium streetlights. A planet perched right at the Sun's maw shouldn't harbor any water, let alone ice, or so researchers thought. But in the 1990s, scientists at Goldstone in California and the Arecibo radio telescope in Puerto Rico directed a stream of radar signals toward Mercury. The teams were astonished to observe two brightly reflective spots at the poles, likely icy deposits. In 2012, MESSENGER confirmed that the ice at Mercury's North Pole was frozen water. Laser measurements on board identified carbon-rich material on the surface that insulates an ice pack underneath. Mercury has managed to cling on to its water because it has pockets in permanent shadow. Relative to its orbit around the Sun, the planet spins perfectly upright, like a soldier at attention facing a commanding officer. That means the impact craters near the poles have insides that never see any daylight. Temperatures within these divots dip below minus 173 degrees Celsius, close to the temperature where nitrogen gas liquefies. It's cold enough that ice can be stable over geological timeframes. And as on most other rocky planets, the water on Mercury probably came from asteroids that crash-landed onto the surface. This water hides in Mercury's craters, untampered with since primordial times. On other terrestrial planets in the solar system, geological processes such as weather cycling have scattered the externally delivered water all around the globe. If scientists want to sample ancient ice in its pristine form in the solar system, the best source is probably Mercury's poles. Mercury defied expectations again when MESSENGER detected volatiles on the sun-scorched world. Volatiles are chemicals that can jump between solid and gas phases in a short temperature change. Mercury already proved it sheltered water, a volatile, but MESSENGER found others such as sulfur, potassium, and chlorine that easily vaporize at moderately high temperatures. These volatiles are distributed all across the surface of the planet. For its size, Mercury contains as much volatile content as other terrestrial planets in the solar system that are farther from the Sun and hence much colder. Where the volatiles come from and how Mercury has retained them are still matters of scientific debate. Some researchers think that the volatiles came from underground relatively recently, while others think the chemicals have persisted on the surface since an embryonic Mercury condensed from its protoplanetary disk. The volatiles on Mercury raise questions. For example, if planets that edge up against their stars have volatiles, especially water, could these locales also be habitable? Well, it's possible that Mercury once held the ingredients for life. Indeed, Mercury has irregular depressions in the ground called hollows. Mariner 10 first glimpsed them in 1975. Then, MESSENGER photographed these shallow tracts at fine resolution. The depressions span from a few dozen feet to over a mile across, and they may be as deep as 120 feet. They look like the soft, airy insides of a sourdough loaf cut open. The hollows may be the doing of volatiles, scientists theorize. Since the atmosphereless Mercury has no rain or wind to carve the land, surface features like hollows can only be formed from other processes, such as the ground leaking volatiles into space. Hollows are relatively young formations, about 100,000 years old on average, compared with some 4 billion-year-old impact craters on Mercury. Scientists think hollows are still forming today, and hollows are unique to Mercury. No other celestial body in the solar system seems to present similar pockmarks. In recent years, scientists have identified other structural formations on Mercury. Chaotic terrains, jumbled ridges that look like a failed game of Jenga, cut up vast swaths of the land. Some researchers think the chaotic terrains are the result of the ground wafting volatiles until it loses structural integrity and collapses. Other scientists think that chaotic terrains form after ripples from an asteroid impact encircle the planet and meet on the opposite side of the globe. In addition, Mercury's topography also provides clues that volcanoes once spewed lava on the planet. Mariner 10, first glimpsed and then Messenger later confirmed that glossy plains spread across Mercury's surface. Each plain suggests pooled lava smoothed over older craters and ridges. Researchers think that magmatic volcanism halted on Mercury anywhere between 1 billion to 3.5 billion years ago, due to planetary cooling and contraction that plugged up the magma's escape routes. Mercury has also shown signs of another kind of volcanism, explosions. If streaming lava is like a runny nose, then explosions are the volcanic equivalent of a sneeze. Irregular pits several miles across and more than 2 miles deep hint at ancient pyroclastic volcanoes that self-destructed. Scattered around these pits are deposits that researchers think are ejecta from the explosion. These types of volcanic bursts are probably caused by volatiles underground. When these buried chemicals rise to the surface, they expand in volume. Eventually, the pressure buildup of gases causes the volcano to pop, like an overfilled balloon. But volatiles, a chemical category that includes water, are essential for sparking and supporting life as we know it here on Earth. So, their potential presence on Mercury is an intriguing development. Astronomers now speculate that beneath the scorching surface of Mercury, the closest dwarf planet to the Sun, there could be signs of life. But how could volatiles, which are essential to life here on Earth, survive on a planet whose daytime temperatures soar to 430 degrees Celsius and drop to minus 180 degrees Celsius at night? Alexis P. Rodriguez, a researcher at the Planetary Science Institute in Arizona, explained that while the planet's surface swings wildly between temperature extremes, just below the surface, temperatures are milder. In the words of Rodriguez, it's likely that there was some sort of water that formed in part of Mercury's crust. But the team cannot yet tell exactly what volatiles were present when the planet's surface broke apart. While the mystery remains, a completely unexpected discovery made by NASA's Messenger spacecraft revealed that a 10-mile-thick diamond mantle may lie beneath the crust of Mercury. While instances of such valuable encrustation might sound tantalizing, turning these precious stones into fashionable jewelry remains an impossibility due to their inaccessible location deep within the planet. However, these gems could hold the key to unraveling some of the big unanswered questions circling around Mercury composition and its rather curious magnetic field. These diamonds may facilitate heat transfer between the core and mantle, thereby creating temperature differences and causing liquid iron to circulate, a process that would kickstart the creation of a magnetic field. The discovery of a potential diamond layer within Mercury opens new avenues for planetary research and composition studies, not only of Mercury, but also of other celestial bodies. Understanding the unique geological characteristics of Mercury could provide deeper insight into the formation and evolution of the solar system. The new discovery also prompts a reconsideration of the processes involved in planetary formation. Diamonds are typically associated with high-pressure environments, suggesting that similar conditions may exist in other distant rocky exoplanets and moons within our solar system. Studying extreme planetary conditions can reveal not only the composition of these bodies, but also the historical processes that formed them, leading to a more comprehensive understanding of geology across the cosmos. The potential discovery casts a new light on the evolution of carbon-rich exoplanets. The process that led to the formation of a diamond layer on Mercury could also be at play on other planets, possibly leaving similar traces. The arrival of the Bepi-Colombo spacecraft, a joint mission of the European Space Agency and the Japan Aerospace Exploration Agency, in 2025 will provide better opportunities to delve deeper into this intriguing discovery. Bepi-Colombo was launched in 2018 on a complex trajectory to the solar system's innermost planet. The ESA reports that the spacecraft's thrusters have lost some power. Bepi-Colombo's mission is to complete a comprehensive investigation of Mercury's magnetosphere, magnetic field, and internal and external structure. But traveling around in the inner solar system is complicated, and the Bepi-Colombo spacecraft will use more energy getting to Mercury than it takes to get to Pluto. The spacecraft will perform 9 planetary flybys before reaching its destination at the end of 2025. Bepi-Colombo has already performed 1 gravity assist at Earth, 2 at Venus, and 5 at Mercury. It'll perform 1 more at Mercury in January 2025. The Mercury Transfer Module, or MTM, is the part of the spacecraft that delivers a pair of orbiters to Mercury. On April 26th, as the spacecraft was about to execute its next maneuver, the MTM didn't deliver enough electrical power to its thrusters. A team working on it restored the thrust back to 90% on May 7th. But the MTM still isn't delivering enough electricity to get back to 100% thrust. Despite the power problems, the spacecraft is on track to complete its final Mercury flyby. A team is working to maintain the current power level and to understand how the diminished thrust will affect future maneuvers. They're also working on restoring full power to the thrusters. To facilitate this, the mission's flight control team at the European Space Operations Center in Darmstadt, Germany, has arranged additional ground station passes. Bepi-Colombo employs a solar electric propulsion system. 2 15-meter-long solar cells gather energy and deliver it to 4 ion thrusters that use xenon propellant. The thrusters are mounted on gimbals, making them aimable. Bepi-Colombo consists of 3 separate spacecraft. The Mercury Transfer Module is kind of like a tugboat, delivering 2 separate orbiters to Mercury. One of the orbiters is the Mercury Planetary Orbiter, and it carries 11 scientific instruments, including cameras, several spectrometers, a magnetometer, and others. The other one is the Mercury Magnetospheric Orbiter, largely built by JAXA. It carries 5 groups of instruments, including 1 group that will study the plasma and neutral particles from the planet, its magnetosphere, and the solar wind. While waiting for the first data obtained by Bepi-Colombo, scientists also put their hope in another tool, the James Webb Space Telescope. The Supreme Space Telescope comes with significant advantages over any previous mission. First and foremost is its size. James Webb features a 21.7-foot mirror composed of 18 gold-plated hexagonal segments. This colossus gathers more than 6 times as much light as the Hubble Space Telescope's 7.8-foot mirror, so it can record light from objects 6 times faster than its predecessor. But Webb's sensitivity to infrared light is the real game-changer. The Space Telescope can view wavelengths from the red end of the visible spectrum to the mid-infrared. Hubble's optics are optimized to record radiation from the ultraviolet to the near-infrared, with the majority of its sensitivity centered on visible light. Perhaps surprisingly, in its intended infrared domain, James Webb generally won't resolve finer details than Hubble achieves in optical light. Although resolution increases with mirror size, it also diminishes with wavelength. Observing in the infrared allows astronomers to see galaxies that existed less than 1 billion years after the Big Bang. These distant objects emit ultraviolet and visible light, but the expansion of the universe shifts this radiation to longer infrared wavelengths. Peering into the infrared is the only way to observe these young galaxies from Earth's vicinity. The same holds true for newly forming stars. The dust that envelops infant suns scatters visible light, hiding what lies within from our eyes, but it lets infrared radiation largely pass through. Despite its focus on distant galaxies and star formation, James Webb is an all-purpose observatory. Its powerful infrared eye sees details in solar system objects beyond the reach of conventional telescopes. Early observations include studying cloud belts on the gas and ice giant planets, tracking cloud formations on Saturn's largest moon, Titan, exploring Pluto's climate, and probing many of the smaller asteroids and trans-Neptunian objects that populate the outer solar system. The telescope even observed the asteroid moonlet Dimorphos in September, when NASA's double asteroid redirection test slammed into it. The impact slightly changed the object's orbit around its parent body, Didymos, helping the space agency assess its ability to alter the course of potentially hazardous asteroids that could cross Earth's path. Thus, it's not far-fetched to think of the Space Observatory can take a closer look at Mercury, unlocking the subterranean secrets of the closest planet to the Sun. In the latest observation, using James Webb, astronomers discovered that Ariel, a moon of Uranus, could be hiding in a buried liquid water ocean. The discovery could supply an answer to a mystery surrounding this Uranian moon that has perplexed scientists. The fact Ariel's surface is covered with a significant amount of carbon dioxide ice. This is puzzling, because at the distance, Uranus and its moons exist from the Sun, 20 times further out from the Sun than Earth. Carbon dioxide turns to gas and is lost to space. This means some process must refresh the carbon dioxide at the surface of Ariel. Previous theories have suggested this happens as a result of interactions between Ariel's surface and charged particles trapped in Uranus's magnetosphere that provide ionizing radiation, breaking down molecules and leaving carbon dioxide, a process called radiolysis. However, new evidence from the Webb telescope suggests the source of this carbon dioxide could come not from outside Ariel, but from its interior, possibly from a buried subsurface ocean. Because chemical elements and molecules absorb and emit light at characteristic wavelengths, they leave individual fingerprints on spectra. The team behind this discovery used James Webb to gather spectra of light from Ariel, which helped them paint a picture of the chemical makeup of the Uranian moon. Comparing this to simulated spectra from a chemical mix in the lab here on Earth revealed to the team that Ariel has some of the most carbon dioxide-rich deposits in the solar system. Not only did this add an extra 0.4 inches of thickness to the ice on the side of the tidally locked Ariel that permanently faces away from Uranus, but it also revealed clear deposits of carbon monoxide for the first time. As team leader Richard Cartwright from the Johns Hopkins Applied Physics Laboratory, or APL, said in a statement, "It just shouldn't be there. You've got to get down to 30 kelvins, minus 405 degrees Fahrenheit, before carbon monoxide's stable. The carbon monoxide would have to be actively replenished, no question. That's because Ariel's surface temperature is, on average, around 18 degrees Celsius warmer than this key temperature." Cartwright acknowledges that radiolysis could account for some of this replenishment. However, observations from Voyager 2's 1986 flyby of Uranus and its moons and other recent findings have suggested that the interactions behind radiolysis could be limited because Uranus's magnetic field axis and the orbital plane of its moons are offset from each other by about 58 degrees. That means that the majority of the carbon-oxygen compounds seen on Ariel's surface could be created by chemical processes in a liquid water ocean trapped under ice on Ariel. Once created in the seep water ocean of Ariel, these carbon oxides could then escape through cracks in the icy shell of the Uranian moon, or could even be explosively ejected by powerful eruptive plumes. Scientists have suspected for some time that the cracked and scarred surface of Ariel may indicate the presence of active cryovolcanoes, volcanoes that erupt plumes of icy slush rather than lava. These plumes could be so powerful that they launch material into Uranus's magnetic field. The majority of the cracks and grooves seen on the surface of Ariel are located on the side of the moon that faces away from Uranus. If carbon dioxide and carbon monoxide are leaking from these features to the surface of the Uranian moon. This could explain why these compounds are found in greater abundance on this trailing side of the icy body. In addition, James Webb also picked up more chemical evidence of a subsurface liquid water ocean. Spectral analysis hinted at the presence of carbonate minerals, salts created when rock meets and interacts with liquid water. As Cartwright explained, if our interpretation of that carbonate feature is correct, then that is a pretty big result, because it means it had to form in the interior. That's something we absolutely need to confirm, either through future observations, modeling, or some combination of techniques. Uranus and its moons haven't been visited by a spacecraft since Voyager 2 almost 4 decades ago, and this wasn't even the spacecraft's primary mission. In 2023, the Planetary Science and Astrobiology Decadal Survey emphasized the need to prioritize a dedicated mission to the Uranian system. Cartwright believes such a mission would present an opportunity to collect valuable information about Uranus and Neptune, the solar system's other ice giant. Such a mission could also deliver vital data about the other potentially ocean-bearing moons of these systems. This information could then be applied to extrasolar planets or exoplanets beyond the solar system. As team member and NASA Applied Physics Laboratory scientist Ian Cohen said, all these new insights underscore how compelling the Uranian system is. Whether it's to unlock the keys to how the solar system formed, better understand the planet's complex magnetosphere, or determine whether these moons are potential ocean worlds, many of us in the planetary science community are really looking forward to a future mission to explore Uranus. In another remarkable study made by James Webb, astronomers have investigated a new super-Jupiter planet that is one of the coldest worlds ever seen outside the solar system. The exoplanet is located in the triple star system Epsilon Indi, which sits around 12 light-years away. The planet is designated Eps Ind Ab and has a mass around 6 times that of Jupiter. It orbits its red dwarf parent star at a distance similar to that between Neptune and the Sun. This gives the world a surface temperature of around 0 degrees Celsius, and means one orbit of the planet takes around 200 Earth years. The Webb telescope was able to image the exoplanet using the sensitive infrared capabilities of the mid-infrared instrument. The investigation of Eps Ind Ab could help astronomers better understand the evolution of gas giant planets and their systems. This is the first time that the powerful space telescope has been able to image an exoplanet that wasn't previously imaged from the ground. Eps Ind Ab is also the coldest exoplanet James Webb has been able to study thus far. That's why scientists were excited when we realized we had imaged this new planet. To their surprise, the bright spot that appeared in our MIRI images did not match the position we were expecting for the planet. They added that previous studies had correctly identified a planet in this system, but had underestimated the super-Jupiter gas giant's mass and orbital separation. The team was able to correct this with the help of James Webb. The crew determined the planet has a highly elliptical, or flattened, orbit that, at its closest, brings it to a distance about 20 times the distance between Earth and the Sun. At the furthest point in its orbit, Eps Ind Ab is 50 times further away from its parent star than the average distance between Earth and the Sun. The world's parent star, a red dwarf named Eps Ind A, has 2 stellar companions. Both are brown dwarfs, or failed stars, named as such because they're objects that form like stars but can't gather enough mass to trigger nuclear fusion processes in their core that define what a main sequence star is. That's all the information that we have for you today. Don't forget to give us a thumbs up if you enjoyed today's episode, subscribe if you haven't already, and hit the bell so you never miss out on future episodes. And be sure to also tell us what you think about today's content. Everyone's support motivates us to continue delivering quality content and to always improve. As always, thanks for watching, and we will see you next time. The moon has held our imaginations for millennia. It has a historical and cultural significance that really seems to resonate with people. Anyone in the world can look up at the night sky, see the moon, and understand how amazing it is that a spacecraft built by humans is roaming around the surface. Lunar exploration began in earnest in the 1950s, with the United States and the USSR developing and launching robotic spacecraft. In 1959, the USSR's Luna 1 was the first spacecraft to fly by the moon. In 1966, Luna 9 achieved the first soft landing, and in 1969, the US's Apollo 11 achieved the first human landing. In the decades since, many nations have contributed to lunar orbiters and landers. Till today, the interest in the moon still is driven by similar goals as in the first space race that occurred more than a half-century ago, demonstrating technological capabilities and inspiring young people and the general public. But the difference is that the new moon race is not the private playground of the two powers. We now have many participants in the Moon Lander Club. For instance, early this year, a Japanese spacecraft has soft landed on the moon, making Japan only the fifth nation in history to achieve the feat. Called Smart Lander for Investigating Moon, or SLIM, the car-sized robotic lander. Initially launched in September 2023, JAXA's Smart Lander for Investigating Moon, or SLIM, a car-sized robotic lander, took nearly 4 months to slowly reach the moon's vicinity and finally entered lunar orbit on December 25, 2023. It then spent 3 weeks gradually lowering its orbit down to just 15 kilometers in altitude before beginning its landing attempt on January 19th. It is the second Japanese spacecraft to attempt a landing on the moon. The first, the Hakuto R mission from the Japanese firm space, crashed into the lunar surface in April 2023. Only the US, the former Soviet Union, China, and, most recently, India, had successfully landed on the moon before now. The mission's primary goal was to test a new method for extremely precise automatic lunar landings, earning SLIM the nickname Moon Sniper at JAXA. The mission had a targeted site that is just 100 meters wide, in contrast with the kilometers-wide landing zones of previous missions, such as the crewed Apollo landings. The demonstration of that pinpoint landing is the symbol of the project, says Yui Nakama of the European Space Policy Institute. SLIM sought to reach this precision thanks to cross-checking its position against detailed mapping of the moon's surface by Japan's Kaguya orbiter and NASA's Lunar Reconnaissance Orbiter. Using onboard navigation cameras and autonomous image processing, the spacecraft continuously scanned the surface and identified craters and boulders to adjust its descent in hopes of a safe pinpoint landing. Having lowered its orbit to an altitude of about 5 kilometers, the spacecraft then began a vertical descent, free-falling to an altitude of 500 meters before firing its thrusters to hover and scan the surface below for obstacles. It next dropped to 50 meters and performed another hover and scan until, tilting on its side, it fell to the surface from a height of 3 meters onto the slope of Scioli crater. The touchdown should have been gentle because of the moon's weaker gravity, as well as cushioning from 5 small spherical shock absorbers. The whole landing procedure lasted 20 minutes, referred to as 20 minutes of terror by SLIM sub-project manager Kenichi Kushiki in a blog post last year, and was followed by an agonizing extended wait as mission controllers struggled to understand what had befallen the spacecraft on the lunar surface. Demonstrating such a precise landing could be a valuable tool for targeting regions at the moon's poles that receive permanent sunlight to prolong the lifetime of landers, or for visiting scientifically rich locales. According to Osinski, who is part of the geology team selected by NASA for upcoming human landings that the agency has planned for the water-rich lunar South Pole, it opens the door for going to more scientifically interesting places. We want to go to big boulders or rocks exposed in crater walls. You've got to be sure you're not going to hit any of those on landing. However, things didn't go entirely to plan that day. It's been a wild ride for Slim, ever since it made a precise touchdown on the rim of Scioli crater on January 19th. It ended up upside down. Images of Slim taken by the baseball-sized robot rover Lunar Exploration Vehicle 2, or SORA-Q, which was released by the spacecraft just before landing, revealed that in achieving this precise landing, Slim came down rotated at 90 degrees, effectively landing on the tip of its nose. Japan Times reported that Slim project manager Shinichiro Sakai explained that JAXA scientists believe that Slim's strangely orientated landing came about as a result of one of its two main engines stopping during the 30 seconds or so of touchdown, and at an altitude of around 50 meters over the moon. This engine failure caused Slim to drift 55 meters away from its chosen landing site. Without the glitch, Slim could have landed as close as 3 to 4 feet from the selected region of the moon. The SORA-Q image shows the shift in position meant that Slim set down on the sloped ridge of a lunar crater. This incline caused the spacecraft to roll westwards onto its nose. But Japan Times added that Sakai said that the loss of the engine was the result of an undisclosed external factor, adding a camera had captured an engine nozzle lying on the lunar surface. This statement really confuses everyone. What exactly is external factor? We just don't know. And so people's imaginations go wild and plots appear in droves. Many scientists believe that the moon may be more than just a natural satellite. In fact, some go so far as to claim that the moon is an alien base. This conspiracy theory arose due to the existence of unusual structures on the moon. The surface of the moon is scarred with tens of thousands of impact craters of various sizes. Scientists suggest this is due to the fact that there has never been an atmosphere on the moon to protect it from bombardment by space debris. There are no natural erosive forces like wind or flowing water to affect its surface, and there is little geologic activity to conceal damage done throughout the moon's history. When you study the distribution of craters, you find the surface is totally saturated. That is, there are craters with increases in the number of craters right down to the smallest scale of size. One of the things that's really interesting about lunar craters is that even though some of them are very large and some of them are very small, they all seem to have the same depth. This uniformity in depth is unusual on a planetary body, where there should be a variation in depth. So why are the moon's craters so uniform? Well, it's really not explainable in terms of conventional or established geophysics. And among the most prominent anomalies is the Tycho crater, renowned for its central peak that some researchers and conspiracy theorists suggest exhibits characteristics of artificial construction rather than natural geological processes. This hypothesis posits that such features could be remnants of ancient alien installations, potentially serving as observatories or bases for monitoring Earth. The Tycho crater's geometric symmetry and the unusual formation of its central peak continue to fuel debates among scientists and enthusiasts alike, challenging conventional interpretations of lunar geology and inviting speculation about the involvement of intelligent extraterrestrial beings. Another compelling lunar anomaly is the Tower, a structure that gained attention after being captured in NASA photographs. Rising prominently from the lunar surface, the tower stands out as a starkly anomalous feature, leading to speculation and theories that it could be a remnant of alien technology. Some proponents of the alien hypothesis suggest that the tower might serve as a navigational beacon or a marker left behind by ancient extraterrestrial visitors, indicating points of interest on the moon, or possibly even guiding interstellar travelers. The tower's mysterious appearance and its potential implications continue to stir curiosity and controversy, prompting calls for further investigation to unravel its true nature and significance. In addition to specific anomalies like the Tycho crater and the tower, broader lunar features such as the Mare Orientale Basin also present puzzling characteristics that have fueled speculation about extraterrestrial involvement. Mare Orientale is known for its concentric rings and complex topography, which some theorists propose could be indicative of a massive spacecraft or a deliberately constructed lunar habitat rather than a natural impact basin. This hypothesis challenges traditional interpretations of lunar formations and invites exploration into the possibility of advanced extraterrestrial civilizations capable of engineering such colossal structures for their own purposes. The enigmatic nature of Mare Orientale continues to inspire debate and intrigue within scientific and enthusiast communities alike, underscoring the complexity of understanding the Moon's geological history and the potential implications for the search for extraterrestrial life. While these hypotheses about unusual lunar structures and their connection to alien factors are met with skepticism by many mainstream scientists, proponents argue that anomalies on the Moon warrant serious consideration and investigation. They advocate for a more open-minded approach to exploring the possibility of alien artifacts or structures, which could offer profound insights into the history of lunar evolution and potentially the existence of intelligent extraterrestrial life beyond Earth. The study of unusual lunar structures not only challenges our current understanding of celestial bodies, but also raises fundamental questions about humanity's place in the universe and the potential for encountering other intelligent civilizations. Scientists expect a giant leap toward understanding the Moon in the near future when lunar exploration is undergoing a renaissance. Dozens of missions, organized by multiple space agencies and increasingly by commercial companies, are set to visit the Moon by the end of this decade. The NASA-led Artemis 3 mission will place the first human boots on the surface of the Moon since Apollo 17's Gene Cernan and Harrison Schmitt left the lunar surface in December 1972. The goal of the Artemis program is to establish a permanent human presence on Earth's natural satellite and an economy based around the Moon. Artemis 3 is scheduled for no sooner than September 2026. However, further delays are likely, and there are many technical challenges yet to overcome. Some might wonder whether it is going to happen at all. I am convinced it will because, unlike the Apollo program, which would be unaffordable in today's climate, the current lunar endeavor will pay off in financial and exploration terms. Extracting water ice from craters at the lunar South Pole could facilitate journeys from the Moon to other destinations, such as Mars, bringing down the cost of space exploration. This is why the booming space industry seems fixed on the Moon as a destination right now. Countries simply cannot afford to miss this boat. The space sector can boost whole economies. In the 1960s, the space race was driven mostly by Cold War-era political and military muscle flexing. There is still some of that in addition to the rush for resources. After 1972, human spaceflight became limited to low Earth orbit as the U.S. switched from the Apollo spacecraft to the Space Shuttle. But in the 2000s, the U.S. announced that it would be building new space vehicles to ferry astronauts to deep space destinations, such as the Moon. That same decade, the U.S. also made a strategic decision to employ the ingenuity and cost-effectiveness of young companies such as SpaceX and Blue Origin. Owned by some of the world's richest entrepreneurs, Elon Musk and Jeff Bezos respectively, they are marked on the outside by passion and risk-taking, but are based on solid business models. SpaceX's enormous Starship vehicle was contracted by NASA to ferry Artemis astronauts between the proposed Gateway station orbiting the Moon and the lunar surface. Starships were destroyed on each of their first 3 test flights. However, the pace at which problems are rectified is remarkable, and, a year on, the 4th integrated test flight of Starship saw both the upper stage and Super Heavy rocket make soft landings. This reaffirms SpaceX's competence in breaking frontiers of innovation and to provide reliable, affordable services. It is renowned for its upright return landings of launch vehicles, essential for human missions to and from the surfaces of the Moon and Mars. However, Jeff Bezos's Blue Origin, has been contracted to land the Artemis 5 crew on the moon later this decade, with its own lander. NASA clearly does not want to place all its eggs in one basket. Recent attempts to land on the moon have highlighted the fine line between success and failure. A fuel leak cut short a mission by private company Astrobotic in January 2024. It was part of a NASA program aimed at kickstarting private transport services to the moon. A thruster malfunction caused Russia's Luna 25 to crash during an attempt at a first landing near the lunar south in August 2023. This occurred as Russia appears to be losing its front-row seat in scientific and commercial space activity. A few days later, India's Chandrayaan-3 lander touched down successfully, making them the fourth nation to softly land on the moon. Japan, as told, followed suit in January 2024 when their SLIM mission landed. Shortly afterwards, Houston-based Intuitive Machines later became the first private company to make a soft, if wonky, landing on the moon. Its Odysseus lander vindicated NASA's belief in private enterprise engagement as the future for sustained lunar exploitation. Long-established aerospace companies such as Boeing are heavily involved in Artemis, but it seems just a matter of time until relatively new kids on the block can go it alone, without the burden of a space agency's bureaucracy and the whims of congressional approval. There are two other relevant players in the moon race. The China National Space Administration, or CNSA's human space program, has been catching up fast. Operating its own space station, Tiangong, it has replaced Russia as the main competitor to NASA. China aims to place boots on the lunar soil by 2030 and build a base called the International Lunar Research Station. They will partner with Russia and various countries with little or no previous space experience, such as South Africa and Egypt. CNSA's lunar program has been flawless, with the uncrewed Chang'e 6 spacecraft landing softly on June 1, 2024. Its objective is to return samples of soil and rock from the far side of the moon. The other player is the U.S. Department of Defense. Its Defense Advanced Research Projects Agency and Novel Orbital Moon Manufacturing Materials and Mass-Efficient Design Program is aimed at developing the capability to build things in space. Its lunar architecture study, Luna 10, to be carried out over 10 years, aims to develop infrastructure for the lunar economy, such as transportation, wireless power generation, and a communications grid. But with this intense effort come ethical questions and a need for enforceable laws and regulations. Is it right to mine the moon? Who owns the land there? We also need to think about whether the water at the lunar South Pole should be consumed until there is nothing left. Dating to 1967, the UN Outer Space Treaty stipulates peaceful activity in space and on other celestial bodies. But these are non-binding principles which say little about economic activity. Neither do the U.S. Artemis Accords, which have been signed by 42 countries as of May 2024. These do not include China and Russia. It is almost certain that by the mid-2030s, there will be 2 lunar bases in operation. Private and state-owned companies will harness its resources, manufacture products, generate energy, and offer stays for tourists. All this comes with technological innovation that may provide solutions on Earth. The race to the moon offers opportunities for peaceful international cooperation and shared economic prosperity. It will also inspire a new generation of engineers and entrepreneurs. For better or for worse, it will be a milestone in the evolution of our species and bring Mars within reach as our next destination. Indeed, Mars has called to us since ancient times. To humans across the eons, the red-tinted speck glinting in the night sky has garnered special attention, with myths and legends wound around its possible ties to Earth. As we observed Mars with telescopes, this fondness graduated into a scientific fascination. Within only about the last half-century, as science has continued to advance, we gained the ability to land scientific instruments on the red planet. Beginning with the Viking probes in 1976 and continuing through the Perseverance rover and its flying companion, the Ingenuity helicopter drone, this robotic exploration has allowed humans to discover complex secrets of Mars. But this is far from the end of our ambitions. Indeed, humans have planned crewed missions to Mars since at least as far back as the 1950s. Scientists and CEOs alike have crafted intricate ideas to establish a presence on the red planet, ranging from small-scale research outposts to major settlements. Elon Musk's plans to put 1 million people on Mars stand as a particularly bold example. However, even with all the money and influence being poured into the goal of putting boot prints in the Martian regolith, there remain considerable doubts that we will ever actually get there. Between economic and ecological problems mounting here on Earth and the major challenges facing even the most basic mission to send humans to Mars, the impetus to spend the money necessary to fund such an initiative has ebbed with the political tides, perhaps more so than any other space mission. Whether it be the dangers of deep space radiation or the possibility of failure in the equipment that keeps them alive, the astronauts who travel to Mars will have to overcome dangers before, during, and after their trip to the Red Planet. But as the thousands of applications submitted to the now defunct Mars One Enterprise clearly show, plenty of people would gladly sign up. What is it about Mars that draws people with such gravitas? It is a barren, desolate place, after all. That much has been clear from the earliest flybys in the 1960s. The days in which dreamers like Percival Lowell and Edgar Rice Burroughs imagined Mars as a flawed but still inviting destination are long gone, replaced by an era in which futurists argue over whether it makes sense to terraform Mars, thereby altering the red planet into something more closely resembling Earth. And, essentially, no one realistically addresses whether such a thing is actually possible. But the fascination remains, and the call of Mars is still as loud as it was to the futurists of the past. There seems to be something of a destiny in this call that makes it all but inevitable that humans will one day step down onto the surface of Mars, much as we once first stepped onto the surface of the Moon. This history itself is instructive. In the earliest days of the space race, many people thought it inevitable that humans would one day set foot on the lunar surface, even if it took decades as opposed to the scant few years promised by visionaries like John F. Kennedy. But the illusion of inevitability is not proof of its existence, in fact, as many failed predictions through history have shown. Even the moon landings were subject to faulty predictions. The New York Times 1920 declaration that rockets could not fly through space due to the lack of air comes readily to mind. But on July 21, 1969, 2 men from Earth stepped onto the surface of the Moon, proving all but the most determined doubters wrong. Will their spiritual successors at NASA and other space agencies one day follow suit on Mars? The first person to step on Mars likely walks among us now, and their moment in history may be coming soon. Let's look at things as they are now. Earlier in 2023, NASA and DARPA announced a partnership to design nuclear rockets, which some attest could be the first step toward a Mars mission. Elsewhere, analog habitats funded by organizations like the Mars Society simulate missions to Mars to prepare potential travelers for the journey. And futurists like Robert Zubrin and Elon Musk draw up plans to send people to Mars by as soon as the late 2021s, with Musk claiming he can establish a colony of 1 million people by 2100. But does any of this mean that Mars pulls us toward its shores any more intensely now than at the height of space-age optimism when visions of grand cities on Mars seemed near to fulfillment? The basic fact is that when humans set our minds to do something, we see it done much more often than not. The South Pole, the summit of Everest, and, of course, the Sea of Tranquility are all evidence of that. So while the exact details of a future Mars mission are unclear, where it will take place, who will be the first to step out of the spacecraft, what flag they will bear, if any, and perhaps, most importantly, when it will happen, The possibility that it does happen is much larger than the chance we will never set foot on Mars. It may take decades, but even if it takes another century, it seems likely that someone will one day become the Neil Armstrong on the red planet. When that one small step takes place is anyone's guess, but the high probability that it will happen seems undeniable. And according to scientists, using the moon as a stepping stone to Mars represents a strategic approach that harnesses lunar resources and capabilities to facilitate humanity's exploration of the red planet. This concept leverages the moon's proximity to Earth and its potential as a testing ground for technologies, systems, and human endurance in deep space missions. Establishing a sustained presence on the moon, such as through a lunar base or outpost, would enable scientists and engineers to refine technologies crucial for Mars missions, including life support systems, habitats, and resource utilization techniques. One key advantage of using the moon as a stepping stone is its relative proximity to Earth compared to Mars. A crewed mission can get to or from the moon in just 3 days, whereas a mission straight from Earth to Mars, or vice versa, would take at least 7 months, with a round-trip mission estimated to last approximately 500 days. That helps to reduce logistical challenges and costs associated with long-duration space missions. Lunar missions could serve as a testing ground for new spacecraft designs, propulsion systems, and autonomous operations that are essential for Mars travel. Furthermore, the moon offers valuable resources that could be utilized to support both lunar and Mars missions. For instance, water ice deposits in permanently shadowed regions of the moon's poles could be extracted and converted into drinking water, breathable oxygen, and hydrogen fuel through electrolysis. These resources could be used to sustain astronauts during lunar missions and potentially be transported to Mars as part of interplanetary exploration efforts. Establishing a lunar base could also serve as a training ground for astronauts preparing for Mars missions. The moon's lower gravity and harsh radiation environment provide an environment similar to deep space, allowing astronauts to acclimate and test equipment in conditions more representative of Mars than Earth's environment. This preparation would be invaluable for ensuring the safety and success of crewed missions to Mars, where astronauts would face long-duration stays in microgravity and exposure to higher levels of radiation. Moreover, the experience gained from operating a lunar base could inform the development of international collaboration and governance frameworks necessary for conducting complex interplanetary missions. Establishing partnerships between space agencies and private companies on lunar exploration could lay the groundwork for future cooperation on Mars missions, fostering a global effort to explore and colonize other celestial bodies. In summary, using the moon as a stepping stone to Mars represents a strategic approach that leverages lunar resources, capabilities, and proximity to Earth to advance humanity's exploration of the red planet. Establishing a sustained presence on the moon through a lunar base or outpost would enable the testing of technologies, systems, and human endurance essential for Mars missions, while also providing valuable training opportunities for astronauts and fostering international collaboration. By building upon lunar exploration efforts, humanity can pave the way for future missions to Mars and beyond, expanding our understanding of the universe and our place within it. The solar system, our cosmic neighborhood, has intrigued and captivated human curiosity for centuries. Within its vast expanse, from the scorching heat of the sun to the icy reaches of the Kuiper Belt, lie numerous mysteries that challenge our understanding of planetary formation, evolution, and the potential for life beyond Earth. One of the earliest scientific discoveries about it was also the most significant. The Earth was not the center of the universe, but orbited the sun. In the centuries since Copernicus redrew the cosmic map, scientists have traveled closer to the heart of the solar system, first with telescopes, then with satellites and spacecraft. They learned about the nuclear fusion that powers our star and countless others and, with the discovery of exoplanets, realized that many stars could be someone else's sun. Today, our understanding of the sun and its subtle mechanisms is more sophisticated than ever before, but it remains incomplete. When you look toward the edge of the solar system, you'll find a vast, dark place in which mysterious entities can easily hide. As a result, researchers have had a field day cataloging all the things that could be lurking out there. From a massive ninth planet and a second Kuiper belt to interstellar visitors and mini black holes, here are weird objects that could be lurking in the darkness out there. Number 1. Planet 9. The largest and most controversial object that could be lurking in our cosmic neighborhood is a hypothetical ninth planet dwelling far beyond the other known solar system worlds, which researchers have creatively nicknamed Planet 9. Scientists first proposed Planet 9 in 2016 to explain the eccentric orbits of several large objects in and around the Kuiper belt, a massive ring of asteroids and other rocky objects that circle the Sun beyond the orbit of Neptune. Some researchers believe these objects are being gravitationally tugged by a massive, unknown world beyond the Kuiper belt. But despite finding even more of these objects in recent years, the actual planet has evaded detection so far. If it does exist, Planet 9 is likely an icy gas giant around 7 times more massive than Earth, which would make it the 5th largest planet in the solar system. However, the planet could be extremely far away, possibly orbiting our Sun once every 10,000 years, which means it would be very faint and extremely hard to spot. Researchers have narrowed down the area where Planet 9 could be hiding, but are limited by the strength of the telescopes currently available. However, with new state-of-the-art telescopes soon coming online, it could be discovered within the next few years. Number 2. Baby black holes. Not everyone believes that Planet 9 is responsible for the orbital anomalies of Kuiper belt objects. Other scientists believe that something equally hard to spot could be gravitationally tugging on these distant space rocks, a mini black hole. Researchers argue that a black hole that's around the size of a moon or planet could exert the same gravitational force as the supposed Planet 9. Black holes of this size are theoretically possible, but have never been observed, which makes this idea somewhat controversial. To prove this theory, researchers would probably need to detect Hawking radiation coming from the black hole, or watch something fall beyond its event horizon. But even if a baby black hole is not masquerading as Planet 9, other researchers believe there could be even smaller primordial black holes in the outer solar system, and that these super small singularities could be making some planets and moons wobble. Number 3. Captured alien worlds. Some researchers believe there could be more hidden worlds, other than Planet 9, in the outer reaches of the solar system. But unlike Planet 9, these hypothetical planets, known as rogue planets, may not have originated in our neck of the woods. Instead, they would be castaways from distant stars that may have been pulled in by the Sun after drifting in interstellar space for eons. Scientists have already detected hundreds of rogue planets zooming across the Milky Way. However, in 2023, researchers proposed that a rogue planet could be lurking near the solar system's edge, even further out than Planet 9. And if that wasn't crazy enough, a 2024 paper also suggested that there is space for up to 5 Earth-size rogue planets toward the edge of our cosmic neighborhood. Number 4. Second Kuiper belt. The Kuiper belt could play a key role in detecting hidden worlds within the solar system, but it may also be hiding a secret of its own, a twin. In 2023, researchers announced the potential discovery of a dozen new rocky objects lurking beyond the Kuiper belt. These hefty space rocks, which are likely all asteroids, are located around 10 astronomical units, that is 10 times further than the distance between Earth and the Sun, from the majority of the Kuiper Belt, suggesting they could belong to a second, smaller belt of asteroids. However, other surveys have failed to identify any more of these extra Kuiper Belt objects, which has left this theory in limbo for now. Number 5. More dwarf planets. After fully fledged worlds and missing asteroid belts, the next largest objects that could be hiding under our noses are dwarf planets. Large space rocks that are big enough to be gravitationally rounded, like planets, but not big enough to completely clear their orbital pathway of debris. The solar system harbors 5 known dwarf planets: Ceres, Haumea, Eris, Makemake, and the ex-planet Pluto. Other candidates such as Gonggong, Quaoar, and Sedna are not officially recognized as dwarf planets, but are often referred to as such by astronomers. All of these mini-worlds lie within the Kuiper Belt or beyond, apart from Ceres, which is located in the asteroid belt between Mars and Jupiter. But as we have already seen, there are plenty of places for objects to hide in the outer solar system. Some estimates suggest there could be dozens or even up to 100 dwarf planets still waiting to be discovered. Until recently, researchers believed that the dwarf planets were mostly geologically dead, except for Pluto, which has an icy supervolcano. However, new data collected by the James Webb Space Telescope revealed that Eris and Makemake may also be geologically active, which increases the chances they or other future dwarf planets could harbor alien life. Number 6. Volcanic comets. Far beyond the Kuiper Belt lies a gigantic reservoir of comets known as the Oort cloud, which extends to around 1,000 astronomical units from the Sun. A very small percentage of these icy objects are what researchers refer to as cryovolcanoes, or cold volcanoes, that shoot dust and frozen gas into space when they erupt. Cryovolcanic comets only erupt near the Sun when solar radiation causes intense pressure to build up within their outer shells, or nuclei, eventually triggering explosive outbursts. However, most comets have highly elliptical orbits, meaning they spend a majority of their orbits floating in the outer solar system before sweeping into the inner solar system every few decades or centuries. This makes it hard to spot which ones are cryovolcanic. For example, Comet 12P Ponce-Brooks, also known as the Devil Comet, made its closest approach to the Sun for around 71 years when it slingshotted around our home star in April 2024. Since June 2023, when the comet began its dive bomb into the inner solar system, the comet has been spotted erupting multiple times. But for the preceding 69 years, astronomers didn't see it explode once. As a result, astronomers suspect that many more cryovolcanic comets are hiding in plain sight within the Oort cloud, and that we'll only identify them when they eventually approach the Sun. Number 7. Interstellar visitors. In addition to suspected rogue planets, the Sun's gravitational might is also capable of pulling in other free-floating objects from interstellar space. However, unlike the supposed captured worlds, a majority of these objects likely pass through our cosmic neighborhood and never return. Astronomers have already spotted 2 confirmed interstellar objects: Oumuamua, an oblong object that made headlines in 2017 after some researchers mistakenly suggested that it could be an alien probe, and Comet 2I Borisov, which was spotted in 2019 as it sailed through the solar system. Other researchers suspect that a tiny meteor that exploded over Earth in 2014 was also an interstellar interloper. Given the tiny number of confirmed sightings, you'd be forgiven for thinking that interstellar objects are rare. However, some researchers estimate that there are between 1,000 and 10,000 of these objects in the solar system at any one time. Some researchers have proposed the creation of special interstellar interceptor spacecraft that could be stashed in orbit around Earth so that scientists can quickly chase and study new objects as soon as they are discovered. But at present, there are no official plans for such spacecraft. Number 8. Killer asteroids. The final objects on this list are the most dangerous, but thankfully, they are among the least likely to be found. The inner solar system is filled with potentially hazardous asteroids, which orbit the Sun close enough to Earth to be considered a threat to our planet, even though most will never get anywhere near us. These perilous space rocks can range in size from city killers that could wipe out large population centers to planet killers, like the one that wiped out the dinosaurs. Similar massive rocks reside in the Kuiper Belt and beyond. However, unlike comets, asteroids don't usually migrate in and out of the inner solar system, meaning these rocks do not pose much threat to us. But this doesn't mean it's impossible. If a massive asteroid did venture toward Earth, it could also be obscured by the glare of the Sun, depending on its position, which could give us very little warning before it snuck up on us. Scientists calculate that potentially hazardous asteroids pose no threat to Earth for at least 1,000 years. However, that calculation is based solely on the space rocks we know about. As we push more robots into space, improve our observational capabilities, and begin to experience space for ourselves, we learn more and more about the nature of where we come from as well as what really hiding out there. But even with our advancing knowledge, we would be naive to think we have all the answers. So much still needs to be uncovered. Here are the most perplexing conundrums our solar system has thrown at us. What killed Venus? Venus is only slightly smaller than the Earth, and so has enjoyed billions of years of a warm heart. But for this planet, sometimes called Earth's sister, that heat has betrayed it. That planet is now wrapped in suffocating layers of a poisonous atmosphere made of carbon dioxide and sulfuric acid. The pressures on the surface reach almost 100 times the air pressure at Earth's sea level. The average temperatures are over 700 degrees Fahrenheit, more than hot enough to melt lead, while the deepest valleys see records of over 900 degrees. If Venus is indeed Earth's sister, she's a twisted one. Like Mars, we suspect that Venus also once hosted a thinner, balmier atmosphere and a surface replete with liquid water oceans. The reasoning here is a little more tenuous than for Mars, where we can literally see the evidence for water before our very eyes. But the thinking is that both Venus and Earth formed in a roughly similar fashion, in roughly the same orbits with roughly the same material. Thus, we should have been born with roughly the same amount of water. Like Earth, most of that water would have been chemically bound up in rock, buried deep in the mantle. But some of it may have leached to the surface or been delivered by hosts of water-rich comets shortly after formation, building up a supply on the surface, once again stabilized by a thick atmosphere. What doomed Venus was not any fault of its own, but our own treacherous sun. As stars age, they gradually brighten. Day by day, it's imperceptible. But over the course of millions of years, it completely changes the character of a star. Billions of years ago, our sun's habitable zone was shifted inwards compared to where it rests now, but with increased brightness comes increased heat, and that habitable zone steadily creeps outwards over time. Did Venus ever host life? We doubt we'll ever know, given the excruciating temperatures on the surface that make exploration nearly impossible. But it's likely that it had water and a rich atmosphere. The basic ingredients were there. But if life did gain a foothold, it did not last long. As our sun aged, Venus got warmer and warmer. On a warmer planet, more water exists as vapor in the atmosphere than as liquid on the surface. At first, the changes were small, with nothing more than a higher dew point to mark the inexorable path to destruction. But at some point in the past, we are not sure exactly when, Venus reached a tipping point. With too much water vapor, the atmosphere of Venus became too good at trapping the heat radiating from the surface. That radiation could not penetrate the haze and make into space, but instead was ensnared within the atmosphere itself, heating it up. What came next was, at least, mercifully quick. Venus entered a feedback loop, dumping more heat into the atmosphere, which boiled the oceans into more vapor, which increased the temperatures, and so on. First, the shallow lakes and streams were gone. Then came the deeper oceans, until every scrap of water was blowing in the winds of the atmosphere. With its proximity to the ever-brightening sun, the water vapor did not last long. Solar radiation pummeled it, disassociating its chemical bonds and sending the oxygen and hydrogen flying away, joining a grim procession beyond our solar system. If Venus had plate tectonics like the Earth, then this is where that process came to end. With no water to act a lubricant, the great slow grinding of the plates seized up, locking the crust in place. This constant churning acts as a natural sink for carbon. The carbon dioxide binds to rocks which get pulled deep into the mantle, preventing too much carbon from building up in the atmosphere. But without the cleansing effect of plate tectonics, carbon dioxide levels rose to dangerous heights, its own ability to absorb radiation from the surface, choking off any remaining hope for rescuing the planet. Eventually, the atmosphere would pile upon itself until it reached its present swollen size. As our sun aged, Venus strangled itself. Venus is not alone in sharing that fate, for the sun has not yet reached its final days. It continues to brighten, bringing more warmth to the solar system day by day, its habitable zone steadily inching outwards with every passing year. At some point, approximately 500 million years from now, Venus will not be alone. The Earth's oceans will boil, our continents will halt their ancient motion, and we will finally be twins with our sister, dead, lifeless, and strangling on our own bloated atmosphere. Where the heck did the moon come from? Before the moon landings, scientists thought they knew how the moon formed. The prevailing theory was that it formed a lot like the planets did, bits of material left over from the formation of the sun, lumping together. But then, Apollo astronauts brought samples back from the lunar surface, and those rocks told a totally different story. The Apollo evidence all pointed to the moon forming from a large impact. The age of the rock samples indicated that the moon formed around 60 million years after the solar system began to form. The type and composition of the samples showed that the moon had been molten during its formation and was covered with a deep ocean of magma for tens of millions to hundreds of millions of years, an environment that would occur in the aftermath of an intensely energetic impact. Lunar rocks were found to contain only small amounts of elements that vaporize when heated, further indicating the moon could have formed in a high-energy impact that let those elements escape. Perhaps most importantly, the rock samples indicated that the moon was once a part of Earth. Basaltic rocks from the moon's mantle have striking similarities to basaltic rocks from Earth's mantle. The oxygen isotopes and other elements sealed into the specimens matched those of Earth rocks too precisely for the similarities to be a coincidence. Meteorites make up another body of evidence. Samples collected by Apollo astronauts come from just a few sites on the moon. But lunar meteorites, rocks sent into space by impacts on the moon that eventually find their way to Earth, provide samples from all over the moon that tell a similar tale of the moon's history. Meteorites originating from asteroids have also been used to help confirm the timeline of the moon's formation. Some show signs of having been bombarded by debris from the giant, moon-forming impact. Finally, more recent studies add the evidence for a high-energy impact that resulted in the creation of a molten moon. Analysis of light reflecting off the moon gives details of the mineral makeup of the moon's surface, and it shows the widespread presence of anorthosite, an igneous rock that crystallizes out of and floats to the top of magma. The presence of anorthosite across the moon's surface reinforces that the moon must once have been covered by a widespread magma ocean that was quite deep, from hundreds to thousands of kilometers. And with humanity's return to the moon through the Artemis program, scientists expect a flood of new information that will help us hone in on a single formation scenario. In the meantime, scientists continue to study existing samples and other information they have now, such as information from lunar orbiters and the growing body of knowledge on planetary formation, to construct computer models that help us understand how the collision might have happened and how it could have resulted in the Moon and Earth as we see them today. The models account for factors like the strength of the colliding objects, the friction between the components, the density of the components, and how materials behave under different temperatures and pressures. Today's advanced computer models can provide a number of very specific outcomes based on variables like these. How did Uranus end up on its side? Uranus is just plain weird, and one of the weirdest things about it is its tilt. Uranus has the largest tilt in the solar system at 98 degrees, which means it spins almost perfectly perpendicular to the direction of its orbit. Astronomers have long suspected that a series of giant impacts early in the planet's formation did the job of flipping Uranus on its side. But new research suggests a much less violent cause, a satellite of Uranus that wandered away. All the planets of the solar system have orbital tilts less than 30 degrees, except Uranus. The whole Uranus system is flipped onto its side, affecting not just the planet's rotation, but also its rings and moons too, which orbit around the planet perpendicular to the planet's motion around the Sun. The odd tilt of Uranus is especially weird considering that the neighboring ice giant, Neptune, has a normal tilt despite the two likely sharing similar formation histories. So what went wrong for Uranus? Astronomers have long suspected that at least one giant impact occurred when Uranus was forming. It's easy enough to imagine. The right collision at the right time would deliver enough energy to push Uranus over while it was still in its protoplanetary stage, and the planet never picked itself back up before forming its system of planets and moons. And scientists have some evidence to support this picture. The solar system was a rather violent place in its youth, so there are plenty of large rocks around to wreak havoc. And Neptune does display slight differences, such as a different temperature and a set of moons with different characteristics, indicating the two planets experienced distinct conditions at some point in their formation. But the impact hypothesis has weaknesses too. There wasn't just one large rock whizzing around the early solar system looking for an unlucky target. There were many. All the planets, especially the outer ones, likely suffered many collisions during their formation. Even the inner planets weren't spared. Earth got smacked by a Mars-sized protoplanet early on, forming the Moon. So if Uranus got hit hard enough to tip it over, why didn't the other planets? Jupiter and Saturn eventually developed thick clouds of gas, which could, over time, have gotten them upright again. But Neptune had a similar history to Uranus, and despite their small differences, the two ice giants are extremely alike. They have similar atmospheres, both have tangled magnetic fields, and have similar sizes, masses, and spin rates. We're left with a dilemma. Perhaps poor Uranus was just extremely unlucky, and there are simulations that support the idea of just the right impact tilting the world. But pure luck doesn't really satisfy the typical astronomer. We should exhaust all the other options before resorting to it. So perhaps the answer doesn't have anything to do with impacts. Perhaps it has to do with moons, as a team of scientists propose in a new paper accepted for publication in the journal Astronomy and Astrophysics and posted to the preprint site, thearchidev.org. According to the paper, Uranus could have been born with or quickly captured a massive moon, and if the moon was big enough, it could have started playing games with the planet's spin. Uranus likely started out with a random but small tilt. Over time, that tilt will precess, as astronomers call it, with the direction of the planet's rotation, wobbling like a gigantic top. Earth does the same thing. Usually, a moon doesn't care about its planet's precession of tilt, but it's possible for a moon to get locked into a resonance pattern, in which the length of time needed to precess matches up with a whole number of orbits of the moon. This resonance allows the gravitational force of the moon to gently tug on the planet, reinforcing the precession. It's like an invisible string attached to the top of the planet. Over the course of millions of years, that tilt gets worse and worse. As this goes on, the moon's orbit would creep steadily closer to the planet. The researchers found that if Uranus once had a large enough moon, it would, within a few 100 million years, be capable of pulling the planet's tilt over 80 degrees. To finish the job, the satellite would then crash into Uranus, locking the planet's tilt at its present value. This scenario would explain why Uranus is so unique. It just had a large enough moon, which is common enough, that slipped into resonance. Not so common that we should expect the same to happen to Neptune. And then it all went sideways from here. How do we know the Oort cloud even exists? The Oort cloud is a vast reservoir of icy bodies, numbered in their billions, perhaps trillions, that make up a ghostly shell around the entire solar system. Though it has never actually been observed, this spherical region is named the Oort cloud, after John Oort, the Dutch astronomer who suggested its existence in 1950. Oort did so to explain the appearance of comets with orbital periods of many thousands of years, reviving a similar idea that had been proposed by Estonian astronomer Ernst Öpik 18 years earlier. But where is the Oort cloud? Frankly, it's a tricky task, attempting to measure distance in space. But it has been suggested that the Oort cloud begins at around a light-year's distance from the Sun, and may stretch as far as a third of the way to the next nearest star, Proxima Centauri. It is a region filled with frozen fragments of water, ammonia, and methane left over from the formation of the solar system, and, though the fragments are fairly insubstantial individually, together they could add up to several times the mass of the Earth. Some of the most impressive long-period and non-periodic comets are thought to have started their journeys here, after being dislodged by some unknown event. The Oort cloud is thought to have sent us comets C1996 B2 Hyakutake, C2011 L4 Pan-STARRS, and C2012 S1 ISON. But it is not the only source of them. Short-period comets are thought to come from somewhere much closer, a region beyond Neptune called the Kuiper Belt, and the area just beyond it known as the scattered disk. We don't have any observations to confirm whether the Oort cloud exists or not, and it is too far to study with space probes. Voyager 1, which NASA has crossed into interstellar space, will not reach it for hundreds of years, by which time it will be long past its useful life. Even New Horizons, which has reached the Kuiper Belt, will be unable to help us. But the theory that the cloud exists is a neat one, explaining how these icy solar system leftovers come to grace our skies. After all, the Oort cloud appears to be out there, but we cannot directly observe it. So, in my books, that is the biggest mystery in the outermost region of our solar system.